Hi. So this is my thesis research, which I recently con- concluded in last month. So the topic of my thesis was multi-class depression detection through tweets using AI. I will give you a brief overview of my thesis. So this is the outline of my thesis, um, of my presentation. First of all, introduction, related work, research gap, problem statement, proposed solution, dataset, and results and evaluation, conclusion and references. So, getting to the point, uh, the main aim of conducting the research was to detect that if a social media user who is using Twitter uh, is suffering from depression or not, and if the person is depressed, what type of depression he or she is facing. So I focused on five types of depression, which is bipolar, atypical, psychotic, postpartum, and major depressive. So previous studies, they basically focused on binary classification, whether a tweet has depression or not. So there was a gap on multi-class classification which hasn't been explored before. So this was my research gap. Uh, Besides that, I also use explainable AI in my model, so that it when the model predicts that a specific tweet displays a particular type of depression. So it also provides an explanation by highlighting the words in the tweet that influence the decision, thereby offering a reasoning for the prediction. So this was my research gap. So these were the inclusion and exclusion criteria. So in the inclusion criteria, the people who have self-reported being depressed currently and in the past are labeled as depressed. Similarly, the tweets which contain the following lexicons, for example, I have bipolar depression, I am suffering from atypical depression, I have a major depressive disorder, etc., are also included. So these were some exclusion criteria. The tweets which were not in English language, they were excluded. Tweets which contain only hashtags or spammy content, irrelevant content, they were also excluded. Retweets were also excluded. Similarly, tweets which were incomplete were also excluded. So these were the research questions, um, which so these were the four research questions. The following lexicons were used to scrap the tweets. So these lexicons were verified by the psychiatrist, uh, and so after consulting from psychiatrist and verifying these lexicons, I then use them to scrap the tools. So this was the pipeline. First of all, dataset scrapping, dataset annotation, pre-processing, feature extraction, classification, explainability, and finally output. So this is the detailed pipeline which explains each of the steps. Um, I used basic. I used machine learning and deep learning models. In machine learning, I used SVM or random forest naive Bayes, In deep learning, I use CNN, LSTM, and BERT. So dataset, as there was no previous work done in multi-class classification, so the dataset had to be self-constructed. So I used Epify, an open source scraping platform, for scraping the tweets. Um, the labeling of the tweets was done by psychology students in a local university. So, so this is the dataset details. Uh, there, there were 20. There were approximately 24K tweets. Um, 11 and a half K tweets contain no depression, um, and you can and the tweets are balanced. The dataset is basically balanced. So these are the results. When I used SVM, the 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 precision recall, FN score, and support results are as shown. Similarly, overall precision recall, FN score, and accuracy are also shown here. So SVM gave an accuracy of 94.4. When I use random forest, it gave an accuracy of 94.7. When I use when I use Naive, it gave an accuracy of 90.9. When I use so this basically comparison of all the machine learning classifiers. So when I use CNN, the accuracy came 92.6. When I use love embedding with CNN, the accuracy came 86. When I used LSTM, the accuracy came 94.5. When I used glove embedding with LSTM, the accuracy came 70.4. When I used BERT, the accuracy came the highest, which is 96. So this is the comparison of all the deep learning models which I used. I also use explainable AI. Um, so I will show you some of the results. So you can see that this is the tweet which this is basically a test tweet which we are giving to our model so that it can predict that which type of depression this tweet contains. So as you can see that it has predicted that the tweet contains postpartum depression, and after that it also explains why it made why the model made this decision by highlighting the words in the tweet uh, due to which the model made this decision. Same is the case for other types of depression: atypical, psychotic, major depressive, bipolar, and finally no depression. So these were the challenges which I faced. Uh, First of all, the dataset construction was basically a challenging task because I had to do it from scratch. There was no research conducted on multi-class classification before, so I had to do it on my own. Similarly, the labeling of the dataset was also a challenge, finding the right individuals who were willing to volunteer and label the tweets. So so these were the challenges which I faced. So there are limitations also. The first limitation is that it is not necessary that a person who is reporting himself to be depressed is actually depressed. Or similarly, in future work we can address more types of depression. In this research, I have focused on five types of depression. In future, we can add some more types of depression also. So I have also submitted my research paper on thesis on a journal. As you can see on the screen, the journal name is Transactions on Asian and Low Resource Language Information Processing. I submitted it on 19th of June and it is currently under review. So that's all from this research. Thank you.